Hey there, welcome back in this certification exam prep on Azure 400, AZ-400 exam called the Microsoft DevOps Solutions. This is section 2, and my name is Peter de Tender, an Azure technical trainer within Microsoft Learning, based out of Belgium, and typically providing weekly Azure workshops to our global customers and partners, where AZ-400 is one of my favorite courses to deliver. Apart from that one, I'm mainly providing the Azure Architect ones as well, 303 and 304. Once more, if you missed session 1, I would say make sure that you stop this video, go back to section 1. It's providing a broader introduction on what you can get out of this C.E.R.T program and covering the first exam objective. Now, in short, we have 7 different sections, and depending a little bit on time, I have no idea yet how it will end up in a full recording video, but probably gonna chunk it up in like 20-30 minutes on average to keep it a little bit digestible. But most important, there's a lot more than section 1 and 2. So with that, let's move on and covering the second exam objective, that's highlighting everything around implementing your DevOps process. We used to have some integration with Pluralsight, where for quite a while we opened up a partnership with Pluralsight, where anyone, not just Microsoft employees, but basically anyone could connect to Pluralsight, create a trial subscription, and from there watching Azure-related videos. Now, if I'm not wrong, only a couple of weeks back, we actually stopped that free partnership, but it doesn't mean that the Azure training videos are now gone from Pluralsight. They're still there, but we're not just making it available for free anymore. So if you want to have access to those video training content, maybe check with your manager if you can get a Pluralsight subscription. If you don't want to use Pluralsight, obviously you don't have to. It's just one of the so many additional learning options we have. But the one you definitely can use is going to our Microsoft Learn platform, where besides the Azure DevOps Labs that I just talked about, you could also find other DevOps related hands-on labs, where it's partly doing hands-on labs, it's partly providing additional Learn modules. Could be video-based, could be reading material, or could be going through a hands-on lab. So more than a valid additional resource to go through. So with that, welcome in, I would say, the more technical topic, where again, out of the C.E.R.T program, the main idea is that we're gonna help you like adding that extra little bit of information out of our trainer experience to hopefully get you through the exam. So we're not going to do any demos. We're not drilling down on specific exam questions because honestly, even we as trainers, we don't have access to the questions, but it's mainly helping you in getting some confidence out of following the videos here, where you could look at it like 2 different ways. If you go through these videos in condensed format and you go like, well, this is interesting, but I have no idea what Peter is talking about, it means that honestly, you're not ready for the exam. If on the other side you go like, well, it's an entertaining session, but I didn't really learn anything new anymore, that probably means you're completely, totally ready for taking the exam. So whatever way you look at it, you're always going to get some benefit out of it. So the first technical exam objective in this larger topic is understanding your DevOps source control. And source control, sometimes described as version control, is really the baseline of your DevOps mindset, because in the end, it all starts with source code. Whether you're building an application that you want to publish in Azure App Services, inside VMs, in AWS, in Google Cloud, in your on-prem environment, or you want to run Azure template deployments, maybe Terraform deployments, that's what we mean by version control / source control. Where the first message is that in the overall DevOps concept, we typically detect 2 different scenarios. A long time ago, a centralized repository that we called TFVC, Team Foundation Version Control. And Team Foundation was known as a centralized system, which means all your developers are connecting to a centralized repository, and from there checking in code, updating, making changes, waiting for approvals, and so on. We're now with mainly Git, and Azure DevOps repos is the technical source control component within Azure DevOps. It's 100% Git compatible, Git enabled, and that's where we talk about a distributed model. Now it means that your developers are, or DevOps engineers, not just developers, are connecting to a shared source control location. Could be GitHub, could be GitHub server on-prem, could be Azure DevOps repos. But before they get access to the source code, they're gonna clone the specific branch towards their local machines. And from there, making changes to the source code, committing the changes back to the centralized environment. That's where pull requests are coming in. And from there, merging the pull request changes and ending up in a new version of your application source code. So the couple of keywords here is centralized, quite important, decentralized or distributed for Git, which means the Azure DevOps repos. And I also talked about branches and pull requests. So what is this thing called a branch? So what you have with a branch is multiple DevOps engineers starting from typically a main branch that we used to call master branch before, but we're not talking about master anymore. So it somehow rebranded to the main branch, and that could be your starting point. From there, developer or DevOps engineer person one is cloning the original starting source code to their local machine, committing changes, and sending them back to the Azure DevOps repos. That mechanism is managed out of a branch. So what's important with branching? And by the way, if you missed section 1, just a reminder that all the blue boxes we have here at the bottom is pointing to Azure documentation, Azure DevOps documentation, describing a lot more details about branch strategies, about branching overall, about security, how do we handle the permissions, to just give you that additional level of content instead of just going through the presentation itself. But most important, there is no DevOps source control without branching, without pull requests. From there, we're going to move on and integrating our source control inside our pipeline processes. So we start with implementing source control. That's where all the source code lives. And from there, we're going to integrate it into our CI/CD pipelines. If you don't know what a CI/CD pipeline is, that's what I already covered in the first section. Once you have your pipeline in place, like in this example, I'm using a .NET application that I want to publish in Azure Web Apps. And to do that, I'm connecting to my source control. That's where all my source code lives. I'm compiling the source code by injecting the NuGet packages, because again, it's a sample pipeline for a .NET application. Running a package restore, building my .NET application, running some Visual Studio integrated testing, and from there, I'm publishing my source code into an Azure Web App instance. So it starts from source code, and from there, you're going to run your pipelines, where you can choose private and hosted agents. A private build agent is where you as an organization will create your own virtual machines and using those ones to literally trigger and run the pipeline. The other option is using Azure default Azure pipelines, and that's where you get access to Azure virtual machines, already pre-baked hosted environment available for you as the consumer, where you can choose different Windows platforms, 16 or Windows 19. You can choose different Ubuntu flavors for Linux depending apps, and you can also use macOS as a build agent. From there, you could also integrate with third-party systems. So typical architecture could be Jenkins to create a build, and using Azure DevOps release pipelines to actually run the deployment and move it into a running state in an Azure backend. So for the exam, you need to know the difference between private hosted agents. You need to know a little bit about the integration with third-party tools, and you should also be able to identify any strategy for building pipelines. Do we need a build pipeline? Do we need a release pipeline? Can we use one single pipeline to compile the software and publishing it, and anything else that's important? And last item here, if you build your pipeline itself, you need to come up with service endpoints. That's the component in Azure DevOps allowing you to interact with the Azure platform, interact with containers, interact with Kubernetes, interact with AWS, and so on, and also defining your webhooks or agent queues to build up your pipeline stream. Another component that's actually quite important as part of your development DevOps pipeline process is identifying the code flow. So what is the code flow? It's back to version control, branching, pull requests, very important for the exam. Understanding the difference between cloning and forking, where cloning means you're gonna start from the central repo and copying it into your local environment, where forking means you're gonna create a clone, but somehow creating your own version of it. So it's not exactly going back to the backend. And you can also integrate branch policies where, for example, you want to allow or enforce approvals that before you can merge a branch or before you can integrate a pull request, that you need to get approval from your peers, from a distribution list or a security group, maybe your team lead. That could be the concept. And apart from that, a big focus on the exam is around handling security as part of your pipeline. Why security? Because in any application stream, you're going to work with connection strings, you're going to work with secrets, you want to store overall application settings that you could typically store in like a app settings JSON file, in a web config file. We're now moving it into your pipeline, moving it into your version control could be a good practice. The service in the Azure platform to help you with that is Key Vault. So what you can do is integrating Key Vault as part of your pipelines. So the scenario is deploy Key Vault. It's an Azure service component. Within Key Vault, you're going to define secrets. You're going to define keys like a connection string. Secrets could be like a SQL admin user and password that instead of storing it as part of your web config file, you're now going to move it into a secret. And instead of reading out the actual connection string, you're going to read out the Key Vault object. If all this doesn't make a lot of sense to you, I can only recommend you to go to that Azure DevOps Labs environment where we have a full end-to-end lab on Azure Key Vault, starting from deploying Key Vault, integrating security, creating service principals, managed identities, and closing with a pipeline that's going to read out SQL information from your Key Vault service. Now back to version control. Already talked about it briefly, but what's important is knowing that the distributed model is based on Git, where again the older model is Team Foundation, version control, centralized. And you also need to figure out a branch strategy. So you can choose one single branch, the main branch only, or having that multi-branch option where any DevOps engineer could create their own branch, integrating with pull requests and making suggestions where out of the main branch somebody needs to merge it, accept all the changes, and that's becoming the new version of your application source code. And again, at the bottom, a couple of blue boxes with links to additional documentation. The next component in scope for the development process exam objective is creating service connections. So what is a service connection? It's a setting within Azure DevOps where you're going to build out integration with third-party platforms. So easy said, if you build your pipeline, picking up source code, running through NuGet and all the other steps I showed you in a couple of slides back, at some point you want to target the Azure platform. It means that you need to create a service connection, which means you're going to create a service principal or asking one of your admins to create a service principal because you need quite some elevated permissions in Azure AD to actually create that identity object. And from there, handing it over to your service connection. And the idea is that your pipeline, once it starts running, it's not running in your DevOps engineer name, but it's going to use that service principal name. The same for other platforms if you want to integrate Docker Hub for containers, if you want to integrate Kubernetes environments, if you want to integrate with Chef, Puppet, other configuration as code, or maybe interacting with Terraform, AWS, Google Cloud, and other platforms you're looking into, that's where the connections are coming in. Another mechanism to authenticate is using a personal access token, or also known as a PAT. Now, what is the difference between a service principal and a PAT? A PAT is linked to your DevOps engineer account. So you log on, in my case, Peter at Microsoft. I'm logging on to my DevOps environment. And instead of identifying myself as a user, like re-authenticating, creating a token over and over, I can also distill a personal access token, typically used in scenarios where you cannot really authenticate. So maybe you might recognize it from Visual Studio Code, where instead of continuously authenticating, getting all those pop-ups asking you for credentials, you could create your own personal access token. And as you can see in that screenshot, but again at the bottom, some links to other resources, you can lock down the permissions for the personal access token to somehow protect yourself as well a little bit. Once you have your security settings in place, you have the source control. That's where we're going to move to the build and release part, which means we're going to compile, run our pipeline, and typically compiling applications or in a release cycle, that's where we're going to move it into a running state. What's important on the exam to know about build and release agents? Once more, knowing the difference between self-hosted and Microsoft-hosted. So building your own custom build agents or using the pre-provided ones. Supporting Linux operating system based on Ubuntu, different flavors, macOS and Windows 16, Windows 19. Authentication using a service principal or using the personal access token I just talked about. And it also allows you to group different agents together in what we call a pool. What is a pool? It allows you to use more compute, build agent compute power to speed up your deployments, to allow multiple pipelines running simultaneously. That's where the pool concept comes in. If you're wondering what it looks like to use your own self-hosted, self-running environment, communicating to the backend, it's all firewall friendly, one single port, HTTPS port 443. So your on-prem, typically running on-prem virtual machine build agent is interacting with Azure pipelines and the other way around by using HTTPS port 443. And another diagram that simplifies it a little bit, you have your on-prem agents in one pool using build agent 1, 2, 3, and 4. And next to that, you have the target staging servers using server 1, 2, 3, and 4. Out of your Azure pipeline service, which could run as a public cloud service, or if you're using Azure DevOps Server on-prem, the scenario is roughly the same. You're going to build an integration between the build agents and the Azure pipeline service. and that's where your firewall-friendly communication comes in. And again, some links. The slide deck, by the way, is available in the aka.ms/CERT landing page. One last section or last topic in this exam objective is mobile DevOps strategy. What is mobile DevOps strategy? It's where you need to know the details about App Center. Now, App Center is described as a next generation hockey app or code push, typically known by developers, not always by sysadmins or overall DevOps engineers. But the App Center helps you in building, compiling mobile applications. So if your target is Android, iOS, macOS, or the overall Windows apps, that's where you typically see Visual Studio App Center being used to publish the apps, compile the apps, and making them available, running testing, where the actual source code itself is again coming from, for example, Azure DevOps repos, more specifically Bitbucket, GitHub server, or GitHub public repos, if that's what you're allowing within your organization. And again, some additional links. And to close this section, another knowledge check question, where the question is, your company is developing several iOS and Android apps. You must target devices for deployment based on feature sets, and you need to provide a solution to deploy the applications. What solution would you use? Is it Visual Studio App Center? Will you use Azure Pipelines to do that? Are you going to use Azure Artifacts, or are you relying on Azure repos? Just talked about it. Shouldn't all be that hard, I guess, where the correct answer would be Visual Studio App Center. So a lot of the DevOps code compiling scenarios are coming back, but since we're targeting a mobile application platform, we're not going to use Azure DevOps pipelines, but we're going to use Visual Studio App Center. If you need some additional knowledge, learning a bit more about App Center specifically, feel free to check the slide deck and follow that link to the App Center. And with that, I'm done with my second exam objective. And again, to keep the content a little bit digestible, I'm not going to make this video any longer. Hope to see you again in section 3, and thanking you already, and good luck with taking your AZ-400 exam. If you got any questions, concerns, if something was not clear, feel free to reach out. My email alias is petender@microsoft.com. Enjoy the rest of your days.